Hi everyone, Professor Theory here. So what are we going to learn today? Today, I'll be helping you regarding the topic dependent and independent event. It is a fun topic to learn, so make sure you stay until the end of this video. So let's go already. And today, we'll be learning about dependent and independent probability. I'm going to talk about independent one first. And one of the most popular, intuitive way to impart knowledge about this is by using rolling dice example. If we roll 2 dice, then we record down the sum of the numbers appears on each die, then we know that there are 36 possible combinations. For each number that we get on the first die, there is 6 other possible outcomes on the second die. So, by multiplying 6 by 6, then we get 36 possible combinations. NS is the notation of the size of the sample space, and it will be much easier to digest the information if we use a table right over there. So the sum of the two numbers can be anywhere in between 2 and 12. And say that E7 is an event that we get a sum of 4, then from the table up there, then we know that there are 3 possible outcomes to get a sum of 4. So n E4 is equal to 3. Now say that E7 is an event that we get the sum of 7, then by again inspecting the table, then we know that the size or the possible outcome that we get the 7 is 6 times. We can now calculate the probability that a sum of 4 appears after each roll of the dice, and that is equal to n E4 divided by ns. And that is equal to 3 over 36. Not complicated. And the probability of getting a sum of 7 is 6 over 36. And from here, we can figure out that the probability of getting a sum of 7 is twice as likely as getting a 4. Now, let's make things a little bit more interesting. Let's roll the dice twice, 2 times. And the question is, what is the probability that we get a sum of 4 in one roll and the 7 in another? There are 2 ways that we can achieve that. The first way is we get a 4 in the first roll and a 7 in the second. And the second way is that we get a 7 in the first roll and a 4 in the second. So, we can write the probability to be the probability of E4 times the probability of E7 plus the probability of E7 times the probability of E4. And that is equal to 1 over 36. This is an example of independent event because the probability of the second roll does not depend on the outcome of the first roll. Now let's go into the dependent events. We have a container that contains 9 marbles of various colors in it. And we are going to pick up 2 marbles one at a time. So the question is, what is the probability that we pick up a blue marble and then a red marble? That is our activity. Looking into the container, we have 9 marbles in it, so that is the size of our sample space. And there's 3 possible outcomes that we pick up a blue marble, 4 for green and 2 for red. The probability that we pick a blue marble on the first attempt is n blue over ns, and that is the probability that we pick up blue marble on the first attempt, 3 over 9. I can simplify that to become 1 over 3, but I'm going to leave it like that so that we know what is n blue and what ns is. In fact, we can easily figure out the probability that we pick up a green and a red marble, and those are the numbers. But we are interested in the blue marble first, so I remove the 2 probabilities and I remove the 1 blue marble from the container. We have a different situation now. The size of the sample space has now reduced from 9 to become 8. The reason for that is, after we pick the blue marble in the first attempt, we do not put it back there. So the probability that we pick up another color in the second attempt will also change after we have already removed 1 blue marble right from that container. And this is what we call as independent event. And I put a subscript 2 there to indicate that this is the second pick. Now take a look at the number of possible outcomes to pick blue, green and red now. And it looks like the possible outcomes to pick blue marble has reduced from 3 to 2, but the rest retains. The probability that we pick a blue marble in the second attempt is denoted by this symbol. It says that what is the probability that we pick up another blue after we have already picked up one blue in the first attempt. The corresponding to pick up green and red marbles are like this. But we are only interested in the probability of picking a red marble. So I remove the probability of the other two and remove one red marble right out of the container. So by multiplying the two probability numbers, we get the final answer, and that is 1/12. So that's it, we have solved the problem. This is called dependent event because the second attempt is dependent on the first pick of a marble. While in the previous example, the second roll of the dice is totally independent from the first one. So I hope that you have already got the key takeaway from this lesson. Thank you for your time and interest. Make sure you watch another video so that you can learn more about maths. See you again. Bye-bye.